Problem 8. ABCD is the 3 times 4 grid that consists of 12 squares. Draw the diagonal line AC. How many small squares does the line pass through? Okay, so ABCD is a 3 times 4 grid here. So I draw here. So let's draw the diagonal line AC. Okay, so how many small squares does the line pass through? 1, 2, 3, 4, 5, 6. Okay, let's count again. 1, 2, 3, 4, 5, 6. So total is 6 small squares the line passed through. Problem 9. How many pairs of positive integers x, y satisfy 2x plus 3y equals to 24? So we have equation 2x plus 3y equals to 24. And x greater than 0 and y greater than 0 and all integers. So then we have, because x greater than 0, so 3y greater than 24. Then we have y greater than 8. So then y has a value 1, 2, 3, 4, 5, 6, 7. So method 1, let's just plug in these y values and calculate for x. See if we can get the x integer and also greater than 0. Okay, so y equals to 1. So 2x plus 3 times 1 equals to 24. So 2x equals to 19 or 21. Then x equals to 21 over 2. So that's not the integer, so it doesn't work. So y equals to 2. Then we have 2x plus 3 times 2 equals to 24. 2x equals to 24 minus 6, 18. So x equals to 18 over 2, x equals to 9, works. Okay, so we have pair 9, 2. And we also check all these, so we find out is y equals to 3. So quickly calculated, 3 times 3 equals 24, and 2x equals to 15. So x equals to 15 over 2, doesn't work. Y equals to 4, and 2x equals to 3 times 4, 12, 24. 2x equals to 12, x equals to 6, so it works. So then it's 6, 4, and y equals to 5. 2x plus 15 equals 24. 2x equals to 9. So x equals to 9 over 2 doesn't work. X equals to 6. 2x plus 6, 18, 24. So 2x equals to 18, 6. Okay, so x equals to 6 over 2 equals 3. So works, that is the 3 of y. This y equals 6. 3, 6. And y equals to 7. 2x plus 7, 21, 24. And 2x equals to 3. So x equals to 3 over 2. Doesn't work. It's not an integer. So we only have 3 pairs. 1. Okay, so we have 3 pairs. 1, 2, 3. Okay, so the answer is 3. And we also can have method 2. Okay. So method 1, we just plug in y, 7 y values, and got the x. Okay, we erase all the link. So we have x, Okay, so we have a y can have the value 1, 2, 3, 4, 5, 6, 7. And we have the equation 2x plus 3y equals to 24. So because 24 is an even number, so then we know 2x also an even number. So 3y has to be even. For 3y has to be even, so y has to be even number. So so from the previous method, we know y only can have the 7 values. So also y has to be even. So then the method 2, so we limited y only can have that value 2, 4, 6. So let's just plug in, we plug in already as a previous method. So x, when y equals 2, 6, 18, x is 9. So when y equals to 4, 12, x is 6. When it's 6, 18, 6, 3. So we have these 3 pairs. Okay, so answer also the 3. It's the 3 pairs, it's an A. Problem 10, a book has 50 pages. Each page has a page number that starts from 1. So what is the total number of digits used in those pages? So for example, a book has 11 pages. The number of digits used is 9 plus 2 plus 2 equals 13. So why? Because a book has 11 pages. So it's 1 to 11. So we know the page 1 to page 9, we only use 1 digit for 1 page. So that is 9 digits. But for page 10, we use 2 digits. For page 11, we also use 2 digits. So that is 9 plus 2 equals 13. Okay. And we have a book is 50 pages. So that's 1 to 50. So the first from page 1 to page 9, we just have 1 digit on each page. So that is total 9 digits. Okay. So then we have a number from 10 to 50. Okay, page 10 to page 50. So we have 2 digits on each page. But we need to know how many pages from page 10 to page 50. Okay, so let's review a consecutive number list. How we count how many numbers in a consecutive number list? For example, I give you a number list, consecutive number list, 2, 3, 4, 5. Okay, so we need to count how many number in this consecutive number list and inclusive. 2 or 5 are inclusive. So if we use the last number 2 minus the first number of last number 5 minus the first number 2, so we have 3. Actually, we have 4 number. Actually, we need to add 1. So the formula is last number minus first number plus 1. So that is 4 numbers. So 2, 3, 4, 5, right? We have 4 numbers here. So that is our formula, counting how many numbers in a consecutive number list. Okay, so here we have a number list is 10, 11, 12, until 49, and 50. So how many number in this number list is 50 minus 10 plus 1 is 41. So then we have 2 digits on each page, and we have 41 pages. So that's the 82. So we plus 1 and 2. Okay, so 82 plus 9. So we have the total digits used in those page numbers is 91. So which is D. Problem 11. A larger cube is made out of 64 little white wooden equal-sized cubes. 5 sides of the larger cube are colored green. How many cubes have 3 green sides? Okay, so we have this large cube. So 5 sides colored green, and the top face is not colored green. So let's look at these green small cubes. So the corner cube of this one, okay, so we have 2 sides colored green already, and because the bottom face is also colored green, so then we have 3 sides colored green. Okay, so this is a 1, so that is also 1. And this corner cube also 1. So we have a 1 in the back. So total is 4 cubes have 3 green sides. The answer is A. Problem 12. Charlie is calculating a number divided by 6. He misreads 6 as 9 and got a quotient of 13 and a remainder of 4. What should be the sum of the correct quotient and the remainder? Okay, so let's say we have a number n. But suppose Charlie's supposed to divide this number by 6, but he misread 6 as 9. So he divided this number by 9, so got a quotient of 13 and the remainder 4. So from this information, actually, we can calculate what is n actually equals to 13 times 9 plus 4. So that would be 117 plus 4 is 121. So let's use 121 divided by 6, supposed to be. Okay, so then we got 20 quotient and the remainder is 1. So what is sum of the correct quotient and the remainder is 20 plus 1 is 21. So the answer is D. Problem 13. Harry got sick. His primary physician prescribed antibiotics and asked him to take 1 pill every 6 hours. So if Henry took the 8th pills at 8 p.m. on March 6th, so when did he take the first pills? Okay, so Henry take 8 pills and 8 p.m. March 6th. Okay, so let's say, so if it's 8 p.m., let's count back. March 5th. So there's 24 hours between these 2 dates. So then we have 8th. So let's draw a number line. So we have 8th. So we have 7th time and 6th and 5th. Okay, so we have 6 hours, 6 hours, 6 hours. So this is a 24-hour force. So there's 24 hours between 8 p.m. March 6th to the 8 p.m. March 5th. Okay, so then it goes back 4 times. So that is a 4th time to take the pill. Okay, so then let's count back to 8 a.m. March 5th. So that's a 12-hour between. Okay, this is 24 hours. So 6. Okay, so 12 hours. So we have 4th. We have 3 as a 3rd. Then we have the 2nd. Okay, the 2nd. So 6 hours. So that is the 2nd time to take the pill. So then the first time would be 2 a.m. March 5th. Okay, so which is a B? The answer is a B. Problem 14. The 12-sided figure shown has been drawn on 1 centimeter times 1 centimeter graph paper. So what is the area of the figure in centimeter square? So this 1 square is 1 centimeter by 1 centimeter. So the area of this one small square is 1 centimeter. The area of this square is 1 centimeter square. Okay. So then we have this square here is 3 by 3. Okay. So that's 3 times 3 is equal to 9. And we can combine these two triangles, then will become 1 square. So this is 1, 1, 1, 1. So the total area is 9 plus 4 equals to 13. So it's a C.